Hello, good afternoon, or hello, welcome everyone. We will start now with our first webinar for the SmallSat today. I'm Matthias, and beside of me is my colleague Lukas. Sorry, it's for the next webinar. Today we want to take you on a journey, on a very interesting journey of the almost unlimited possibilities of communication challenges. This webinar will be recorded and available in the next day on demand, and I hope you will enjoy it. Today we like to speak about mission requirements, flexibility, adaptive communication solutions, and our success story will be the key facts today. Here on our first slide, you see some missions we are present now or there in the past. A lot of satellites are established with our communication solutions, like transceivers, antennas, and so on. This will now be our first of the two webinars. The second webinar we will have tomorrow, and we will also have a guest today from the Technical University of Berlin, and he will give us very interesting new facts about the last mission of the TUBIN satellite launched in the end of June of this year. Lukas and me, we are employees of the Eiko Wireless GmbH, based in Berlin, Adlershof in Germany, founded in 1999, and we are about 35 employees. We have two business portfolios, but we are one team. One business portfolio is the Eiko Firewatch. It's a terrestrial, Earth-based early fire detection system. And the second business field is Eiko Spacecom. There we are focused now with our webinar today, and we'll give you a lot of facts about this.
Yeah. First of all, I just want to shortly introduce our heritage and what we are doing here at Eiko Wireless. We are not only selling products, we are also designing new products, manufacturing them, qualifying them for space heritage, and also testing each product for our customers. And also by doing this all in-house, as you can see here on the pictures, we are testing and manufacturing ourselves, and we are not only getting our products or our parts somewhere else. Therefore, we are able to adapt our products individually to our customer needs, and also to develop customer-specific solutions in a very short time, and also very cost-effective. Here is an overview of all of our products. The first one was Hispico. It's only a transmitter, but it's still very popular because it's very small and also usable always for especially universities, because it's also very cost effective too. And therefore many universities are having a look at this product. As a further development of the transmitter, the Hispico, we developed a transceiver, the Xlink, which is on the one side the Xlink and on the other side the Xlink Phi. The difference is mainly the Xlink Phi is made for CubeSats. It fits into the CubeSat structure form factor, and therefore we further developed our transmitter into a transceiver. Besides of this development, we also developed various antenna designs for S and X band, from single patch over dual patch up to high gain antennas, for example quad patch antennas. And also parallel to this development, we were part of the next OBP mission, where which will be launched on the Heinrich Hertz satellite, and Matthias will come back to this later. And our latest product is the Xlink. It's an SDR platform, a software-defined radio, as you can see here on the top left of the slide. And on the next slide, you will see how the Xlink is built up. It's, as I told you, it's a software-defined radio, therefore many adaptations are possible. The basic blocks of our Xlink platform are here in front. It's typically an X-band transmitter path and an S-band receiver path. It's always an Ethernet interface included, and it's which is very nice. It's a CCSDS conform protocol. We have different options for the power supply, and by the software we have included in this platform, we are able to adapt it to very customer specific in a very short time, and many needs are covered with this software and this product. And also there are the possibilities to include an S-band transmitter channel or an X-band receiver channel, or combine both transmit channels to one channel to gain more output power. But also further developments are, for example, in radio front and power amplifier as an additional solution to gain even more output power, or to further develop our radio front end. The Xlink is built up from two slides, as you can see here on the top left. One is a software-defined radio and one is a radio front end, and we can individually adapt the radio front end, for example, also to other bands like L-band, which will be on our roadmap, or K-band. And also customer-specific adaptations are here very easy configurable. And
yes, and it's a really very space-saving solution. The form factor is only 90 millimeters by 65 by 25 millimeters, below or about 200 grams in mass. So it will fit in every kind of CubeSat structure, as well as in bigger satellites. And maybe you have seen our headline on some social medias of this 43 dB data rate dynamic range. It's a headline because we can cover with this one product data rates between 4 kilobit per second up to 100 megabit per second. It's only a software solution to adapt this data rate on this very, very huge range. And so we can cover 43 dB of data rate dynamic range. But there are a lot of other things we can do with this very flexible platform. Now we will come to some typical applications besides the normal communication solutions. For instance, we can use it for bringing to use missions. There, the Xlink is the key part for the software-defined radio to generate the different signals, and we can build up different frequency bands. In uplink and downlink, it's possible to cover there a lot of bands like KU, K, KA, or also W band. This will be all possible. Some of them are already realized on real missions. Some will be maybe in the future. And so we have a very flexible solution to adapt it to very different customer requirements.
Yeah, and here, as you saw on the second slide, we have listed some of our customers. As you can see, we are international competitive. We have customers over in the US or in North America, in Europe, in Asia, and also Australia. Only South America and Africa are missing, but I think that's mainly because the CubeSat market started there a few years ago, and therefore it's kind of small. But as you can see here, also satellites we are present on. There are different missions where our products are on board, And therefore, as you can see, we gained a lot of flight heritage with our products. Some satellites are from the Technical University of Berlin, like the SNET mission, where our Xlink is present, or our latest mission, the TUBIN mission, we will come back to later, where our Xlink and also our Hispico is present, and also on many missions are our antennas present.
Yes, and then there's one very important or very successful mission. This is the BSAT-3 from the University of Berlin. It was launched in 2013. It was built for a lifetime of about 2 or 3 years, and it's still in operation in orbit. And so you can see that flight heritage is a big, very big focus of our products.
And here you see a short overview of the written out satellites we are present with our specific products, and also since when the satellite is in orbit, or yeah, and as you can see, our Xlink gained flight heritage early this year, and also our other products and patch antennas already gained a lot of flight heritage.
Yes, and I already told you about this possibility of bringing into use missions. There was one in the last year. We were a part of this, and the main point of this I like to focus on is that we could realize it because we have the whole experience and experts in our house. We could realize in almost 3 months this mission between the concept up to the delivering of the solution of the payload for the customer. There's another one, we spoke already about this. This is the Heinrich Hertz mission. It will be launched in 2 years, and now the payload integration is started, or is already almost finished. One of these components here on the top is the next OBP unit. This is an onboard processing unit with an integrated RF interface and L-band. And there we would like to demonstrate different network coding algorithms in geostationary environment. And so has our unit has to qualify for this geostationary orbits with all these environment conditions.
Yeah, and here is one mission where our Xlink was present, the SNET mission. This one is kind of special because there the Technical University of Berlin represented, or yeah, did an Intersatellite link with our Xlink, and therefore it was very interesting, especially in the context of our current time, where Intersatellite links become more important and more favorable. And this mission is in orbit, or was launched in February 2018 and is still in operation. And also the Xlink was activated also in February 2018, and therefore it also established very successful. It's Intersatellite link. As you can see here on this slide, we represented an Intersatellite link in orbit, and we achieved it already. And therefore we gained a lot of flight heritage and also a lot of experience. Based on this knowledge, we can use, for example, for our Xlink platform too, and also for further developments.
Okay, and now we are at the point that I would like to welcome Philipp Werner from the Technical University of Berlin. Philipp is a part of the chair of space technology. He is the system engineer. Hello, Philipp. He is the system engineer of the TUBIN mission, and he is an expert of mission operations for the TechnoSat and TUBIN mission. And now I would like to please, Philipp, please, can you give us some news about the mission launched in June, and what is the status and what will be the next steps?
Yeah, gladly. Okay, so the TUBIN mission is a nano satellite, microsatellite of about 20 kilogram for wildfire detection using two thermal infrared bolometer cameras with the golden baffles you can see here on the top and a single camera for the visible spectrum. We've launched about a month ago. We're pretty far into our mission already. We've used all components by now. We're taking pictures daily, downlinking them to a ground station. And to downlink all those images of the three cameras, we needed a lot of data rate. And in the early days, we decided to use the HISPICO S-band transmitters of IQ Wireless. We actually have two of them on two slightly different frequencies, so we can actually employ both of them. You can see them here on the left and on the right of the breakthroughs for the cameras in the mounted to the inside of the frame of the satellite. As we went along the project and designing everything, we basically found out that our cameras are able to produce so many big pictures that we're not able to downlink many of them over the two HISPICOs, and pretty far into the project, we decided to also incorporate one of the Xlink transceivers actually, into the mission, which you can see on top, on the left picture, on top of the breakthroughs for the baffles. Actually, mounted on top of the Xlink here is a combiner to combine both transmitter channels into a single signal and to lead it to one of the patch antennas. As you can see on the right side, we have a total of 5 patch antennas, 3 for S-band, actually 2 for downlink and 1 for uplink, which goes into the Xlink as well. And we have in the back 2 small X-band patch antennas, all manufactured by IQ Wireless. And the guys there actually helped us quite a lot in bringing the Xlink into the mission very, very late in the design. Helped us out with ground station equipment to actually test our flight model because we're still waiting on our own ground station equipment basically because of the corona pandemic and holdups at the university. We're still waiting for the parts because there's a lot of time going into acquiring all those things. The guys helped us out quite a lot. We have had the 2 S-band transmitters already in use for about 3 weeks now, and as of now, we're still waiting for our equipment to actually be able to use our Xlink, but it's already working on the satellite and drawing power and stuff, but we just don't have the means right now to receive it. But yeah, that's going to come very, very soon.
How did you manage this to bring this Xlink in such a very late stage of the mission into the TUBIN?
Well, our TUBIN is the second satellite based on our very modular microsatellite platform. The first one was TechnoSat, which looks quite identical and had this HISPICO already too. And based on the modular design, we actually had a couple of connections left from our which were just unused at the time, and so we were figuring, okay, we have a power connection here, and there we have our Ethernet connection to the cameras, to our Ethernet hub. What can we do with those? Can we incorporate the Xlink? And it took us about half a year to figure it out, to get the funding, and then to start integrating it into the satellite. It basically arrived just in time for the integration process of the flight model, because we were so late in the project, but it worked out in the end. We're very excited to actually bring it into use pretty soon.
Is it right that the camera is directly connected to the Xlink for delivering of the payload data?
Not quite directly. It's we have basically an Ethernet switch in the middle between all cameras and the Xlink and our payload data handling module. But the payload data handling module is a microcontroller unit, as the rest of the satellite, and it's not fast enough to actually provide an Ethernet connection with more than 56 megabit that we need to actually feed the Xlink with the data required for the data rate of 56 megabit per second. And that's why we have our Linux camera computers basically directly feed the Xlink. Yeah. But we were already able to confirm the 56 megabit in the ground tests. We have another slower data rate of 12 Mbit for our ground station. The larger one might be a little too much for our ground station, but we'll try to test it in some of the larger ground stations that we can rent, basically.
Very interesting.
So, yeah, we have different data rates selectable in our Xlink. Yeah.
Okay. So we will see in the next weeks or months the results of the tests and the build up of your ground station with very high performance ground station modem, and then we will go on with the project, and hopefully we will have a lot of projects in the future too.
Yeah, but as of now, we're happy to have our two his Pico transmitters serving in dual mode, basically, which works very, very nicely. And yeah, but still, we could take more pictures if we could bring them down all. So that's why we need our Xlink.
Okay, thank you, Philip, for up to now, and
no problem.
Let's go on with our presentation. This was not our Xlink production is going on. You see us 4 of these devices with the mounted combiner, and we have now up to now already up to more than 30 Xlinks delivered to the customers in different modes, like engineering models or flight models. And the story is going on. And so I would say feel free to send us questions, maybe in the chat function. And
yeah, also thank you for your attention, and we are happy here to answer your questions right now. Or if you want to reach out with some requests, you can also contact us directly via our email addresses, as you can see here. Yeah, we are open for questions right now.
And if you like, you can meet us tomorrow too.
Yeah. Tomorrow, our colleague Andreas and I will present the next webinar, 5G IoT Intersatellite links. So perhaps these buzzwords will make you interesting, but here at IQLS, they are not only buzzwords, as you will see in our webinar. What we are doing with these words, and also if you're interested, you can book a private or personal meeting with us, and yeah, we will answer all your questions or direct inquiries right there. You just have to follow our link where you also applied for this webinar. There you will find a section where you can apply for a personal meeting.
And we will be happy to meet you on one of the next exhibitions or conferences. Sorry, the Satellite 2021 will be not there will be not present because the restrictions of the traveling. But definitely we will be in Dubai at the International Astronautical Congress. There we will be present on the German booth with exponents and devices, and we will have a presentation of a data link between the satellite unit and the ground station unit. And maybe you can show us the model quickly. We have also this model here with a realistic installation of a Xlink unit inside and antennas beside for S-band and X-band. and you are welcome to join or to meet us there. And we
also
hope
have a closer look at our products and yeah.
Okay, feel free to send us questions via the chat, or we will stay here maybe for some minutes again, and we will answer our questions. Thank you very much for your attention.